Okay, so so far we looked at general description of the wave. So let's look at the electromagnetic spectrum. So electromagnetic spectrum, it combines the electromagnetic wave. Okay, so there is this spectrum that is based on the wavelength and the frequency of the various electromagnetic waves. So example is light wave. Light is a type of electromagnetic wave. Light is light travels at a speed of v equal to 3 into 10 to the power 8 meter per second, right? Fast. Okay. So remember we said the wave speed v equal to f into lambda. For if we have a light, then instead of v we just write c equal to f into lambda. Okay. So the electromagnetic spectrum looks something like this. I'm not quite sure if you guys can see this. I'm going to kind of start writing a little bit here, not everything, but a little bit of information here. So we have an electromagnetic spectrum here. One, it starts, if we look from the, from wavelength. Okay, so it goes from a lower wavelength to, higher wavelength to lower wavelength. Okay, so this is here we have wavelength representation for wavelength. This part is for frequency band here. So wavelength is measured in meter. Radio wave has the longest wavelength. It's long. Okay, radio wave. Radio wavelength, the wavelength is about 10 to the power 3 meter. So radio, I'm just going to write here lambda in meter, okay? About 10 to the power 3 meter. After radio wave, we have a microwave. Microwave is about 10 to the power minus 2 meters. So microwave is about 10 to the power minus 2 meter. After microwave, so you see radio wave is the longest, the one with the longest wavelength. After that microwave wave, and then after that infrared wave. Infrared, it lies in the region of about 10 to the power minus 5 meter wavelength. Okay, and then after infrared, visible light comes. So visible light is about 10 to the power minus 6 meter. And then ultraviolet, UV light. Okay, ultraviolet, it's the wavelength is about 10 to the minus 8 meter. After ultraviolet rays, we have a X-ray. This is 10 to the power minus 10 meter. So this is kind of about the radius of atom, basically. Okay, 10 to the power minus 10 meter. So getting really smaller, right? Wavelength is getting very small, very small. And then comes the gamma ray. After that comes the gamma ray. Okay, so gamma ray, this is about 10 to the power minus 12 meter. So you see that, so gamma ray has the lowest wavelength, radio wave has the highest wavelength. Okay, and any electromagnetic wave lies between these two. Radio wave, longest wave, radio wave to the gamma ray. Okay, now that was in terms of wavelength, but you guys probably learned, or if you haven't learned, not if you haven't, actually we looked at this briefly, v equal to f into lambda, right? We said, well, this v is actually doesn't depend on this or this here, okay, only for now. Okay, this will change later on. So if we have, if lambda decreases, if lambda increases, what happens? this guy increases, this guy has to go down if this is constant, right? So for the electromagnetic wave, b is just the speed of light c, right? So this is, so if the wavelength increases, the frequency has to decrease, right? So radio wave has the longest wavelength, which means it should have a lowest frequency. That's another way to look at it. So if we go by the frequency, so then I'm not going to write this down, but I'm going to just tell you guys here. So radio wave is at 10 to the power 4 hertz. Microwave is at 10 to the power 8 hertz. Infrared is about 10 to the power 12 hertz. Visible is somewhere in between 10 to the power 12 and 10 to the power 15. Ultraviolet is about 10 to the power 15 hertz. X-ray is 10 to the power 18 hertz. Gamma ray 10 to the power 20 hertz. This is very, very energetic, okay? So meaning whenever the frequency increases, it means it's more energetic, okay? You'll learn this in this semester, sometime in this semester. So all right, so that is and then, oh, if you want to see just pictorial, you see here is the, right, like the wavelength is longer, gets shorter, is smaller, and more repetition here, right? So really the frequency increases here. So this is just the color band here representation. So pretty much everything is dark this side, see guys, until up to almost like up to microwave, and then also from about like X-ray to gamma ray, everything is dark. Up to like radio wave, microwave, everything is really dark. The only thing that we really see, our limited system sees, is only that visible but little bit of tiny window here, in between here. Really between 10 to the power 12 hertz to 10 to the power 15 hertz. Okay? So there are a lot of things that we don't see. Or we don't know much. I think maybe that's the better way to say. Alright, so this is just a summary page here of what we just talked about. Radio waves as wavelength greater than 1 meter, microwaves lies between 1 millimeter to 1 meter, infrared light 700 nanometer to 1 millimeter. So basically the warmth you feel from the sun is actually infrared, okay, primarily IR. Visible light 400 nanometer to 700 nanometer. Remember, this is probably interesting for you guys. Each atom has its own signature color. So astronomer uses this signature color to study about to determine the atomic and molecular properties of a distant stars and other cosmic bodies. Okay, and ultraviolet lies between 10 nanometer to 400 nanometer. X-ray again 10 to the power minus 10 meter to 10 to the power minus 8 meter. X-ray was actually discovered by Wilhelm Röntgen. I don't even know how to pronounce it. Röntgen. He was the first Nobel Prize winner. For physics, not for whole Nobel Prize, for physics. Okay. And then gamma rays is 10 to the power, wavelength lies between 10 to the power minus 14 meter to 10 to the power minus 11 meter, and gamma rays are used in radioactive decay. Okay, so that is about the summary of electromagnetic spectrum. For the next lecture, we'll start with the sound wave. Okay, all right, that's all for today's lecture. Thank you for watching. Make sure you are watching this video. Okay, make sure you take a note, make sure you actually work out the problem or even the example or even some of the derivation. That will kind of help you, it will help you keep your mind focused into the topic, and also it will help you to do the homework problem. Okay, all right, thank you, bye bye.